All right, welcome back. And now we're going to look at another way to do this division process that's a lot easier, but there are restrictions as to when it can be used. So we're going to look at synthetic division now, which is another method for finding that quotient function, that q of x. The only restriction, though, is that the known factor must be of the form x minus k. Now, keep in mind that k might be positive or negative, so that might be a plus or a minus in between the x and the k, depending on what k is. So let's just jump right into some examples, and we'll see how this works. So we want to do division again. So we got our first function, our first polynomial function, and then we have our divisor. So in this case, x plus 2, we want to divide in. Now, how you write this is a little differently. It's not like the long division process, but you want to have like an L-shaped bar here. Now, pretend that you're going to want 2 rows of numbers. So make sure you have a vertical line that's long enough to support 2 rows of numbers, and then we're going to have a line underneath, and then we're going to put another row of numbers underneath that. So 3 rows of numbers. Now, what goes on the inside are the coefficients, and only the coefficients of your polynomial. Now, we got x cubed, x squared, x, and then nothing, and no x at all. So we want to put down our 4, put a little bit of a space maybe, our 8, a negative 9, and a negative 18. So just those 4 coefficients are going to be on the inside, and on the outside is what the value of k is. Now again, be careful. K can be positive or negative based on how it's written. So because this is x plus 2, k is going to be negative. So this case is going to be a negative 2. So that's going to be on the outside. So that's the starting point. Now, how do we divide? Well, it's actually not dividing at all. It's going to be a matter of adding and subtracting and multiplying. So, but the first step is just to simply take this 4 and drop it right down below our line. Now, what do we do next? Now we got to multiply. So whatever number you have on the outside, you have to multiply it by this number and then put that answer up underneath the next coefficient. So in this case, we have a negative 2 and a positive 4, so that's going to be a negative 8. Okay, now we add. If we add those together, we get 0. And then we repeat. Multiply, so negative 2 times 0, and put that result under the next one, which is going to be a 0. And then we add, so that's going to be a negative 9. We multiply, which is going to be a positive 18. And we get 0 for the result. Math is pretty quick, but what the heck does all this mean? Well, we now have the coefficients of our quotient, but we just got to make sure we put them in the right spots. Now, how does it work? Well, this is the remainder. That's the remainder, which is 0 in this case, which is nice. This next one is going to be our constant for our quotient. This is going to be for your x term, and this is going to be for your x squared term. And if we had another number to the left of it, that would be x cubed, and so on. So now that we know this little formula, we can put our quotient together. So we should have a 4x squared, and we don't have an x term at all, so we can leave it out, and then our constant is negative 9. So this should be 4x squared minus 9. Done. Now, once you get the hang of this, you can do synthetic division very, very quickly, but just be careful not to go too fast. Let's try a few more, make sure we have it down. So we got 2x cubed minus 9x squared plus 16 divided by x minus 4. So let's get our L. And because it's x minus 4, k is positive, so we want a positive 4 on the outside. And now let's get our coefficients. So 2, -9, and 16. Uh-oh, what's wrong? What did I do? What did I forget? Well, yeah, there's no x in here. We have to account for that. So we don't want to jump right to 16. We got to keep track of all of those x's, even if they're not there, just like with long division. So let's put a 0 and then put our 16. And now we have all of those terms identified, so now we're good to go. So again, first step, drop down the 2, multiply, add, multiply, add, multiply, and add. So, what do we get for a polynomial from that? So again, remainder, constant, x squared. So 2x squared minus x minus 4. Boom. Much faster than long division, but we can't use it all the time, unfortunately. All right, let's try 2 more, and then we'll end this video. So we got x cubed plus 592 all over x plus 8. Remember, fractions are another way to write division, so it's still the same thing, just looks a little different. So we got a plus 8 here, so that means k is negative. So -8. X cubed is the highest power, so coefficient of that is 1. We're missing x squared, so let's get a 0. We're missing x, so we need another 0. And our constant is the 592. All right. So we'll bring down our 1 and multiply, and then add, and then multiply, and then add, and then multiply, and then add. So, in this case, we do get a remainder. So we just got to make sure we write our final answer correctly. Now, so again, that's our remainder, constant, x squared. So x squared minus 8x plus 64, and then how do we write our remainder? Remember, we put the remainder as a fraction. So there's the top, and what's on the bottom? Think of what we did before. That x plus 8 is what we were dividing into it, so that's what goes on the bottom. So 80 over x plus 8. All right. So, on a roll with this stuff, let's get messy. Let's look at fractional values of k. Ugh. Not pleasant, but we can do it. So, a plus 1/2, so k is negative. And we got a 2, we got a minus 3, positive 4, and a positive 3. All right, so drop it down, multiply. -1/2 times 2, well, that should be a -1. -3 and -1 is -4. -1/2 times -4, well, that should be a positive 2. 4 and 2 is 6. -1/2 times 6, well, that better be a -3. We get 0 remainder again, so that's nice. So this one wasn't as bad as we thought. So we should get a 2x squared. Well, I should probably use the right variable, not x. Look at our variables up there. Don't get stuck in that possibility all the time. And so there should be our quotient. All right, so let's stop there and we'll see some other applications that we can apply using synthetic division. Stay tuned.